This is an example for conducting a t-test. Maybe hit pause and read through this problem. This is supposed to say alpha right there. Let me try again. So read through it and we'll do the state plan do conclude. All right, first step, state. Now we are testing to see if dissolved oxygen levels are too low. So this is like we'll have a double conclusion because I'm going to say something about oxygen levels being lower than 5 or not, and then I'm going to conclude about aquatic life being at risk. So be careful in how you conclude here. Mu, this is the true mean, and they abbreviated for us, so let's use their abbreviation. DO level in the stream. Kind of nice, a short description there. HO, HA, we are looking at means. So we say the mean is equal to the value in question, and it's written right here. So it looks like 5 milligrams a liter is that make or break value. So we're hoping it's 5 mg or higher. But we're worried about the aquatic life being in danger, so we're going to test to see if it's too low. The problem tells us that alpha is 0.5. Then we move on to the plan step. And it looks like they took a sample of 15 random spots in the stream. So random sample. N was 15. So that has me nervous because it's smaller than 30. I skimmed through. I don't see the word normal typed anywhere. So at first I'm at a loss. Doesn't tell us it's normal. Sample size isn't bigger than 30, but they gave us the data. This is actually very typical. They give us the data, so you want to go to your calculator and type it all into a spreadsheet. So maybe hit pause and do that. Grab a calculator, type it all into a list here. I named my list A. Now, typically in a situation like this, whenever N is smaller than 30, and they don't tell you it's normal, you're typically going to see a graph like attached to the problem. And in that scenario, you just need to know what to say. In hindsight, I should have screenshotted this and put it in the problem, but oh well, we were typing it into the calculator anyways. So I see a dot plot here. There's so many things we could look at. I see symmetry. Really, there's just one dot out of line here. That one dot, I wish it was dead center, the stack of 2, but there's one dot that's off center. If you ever are worried about outliers, remember we have a box plot on here. You can look to see if there's outliers, and they're not. No outliers. If you're really interested, if you go to plot type and normal probability plot, it matches these values to the normal curve. So the black line is where the normal curve would fall, like each corresponding percentile or z-score. And it gets a little out of line right up here on the top right, but otherwise they fall pretty close to the black line. We're going to approximate this thing as a normal distribution. So back to the problem. N is less than 30. Graph, dot plot, box plot, whatever you want to reference, looks symmetric with no outliers. If you were to reference that normal probability plot thing, you would say dots look linear, very close to the normal line. And that's it. distribution is approximately normal. All right, move on to the do step. We had to do this, we had to type the data into the calculator anyways, because notice this thing is lacking X bar and S. I don't know what those are. I know DF, N is 15, so DF is 14. But I need T, X bar, S, and the p-value. So back to the calculator. We're on the spreadsheet. Press menu, stats, stat tests, and we are going to run a t-test. Now, the main reason we do not run a z-test is the same reason we did a t-interval last chapter. I have no idea what the population standard deviation is. We only know what the sample standard deviation is. So I'll say that one more time. I'm picking t because we only have sample standard deviation, S. We do not have sigma, the population standard deviation. They would have had to type that in the paragraph. They didn't type it. They could have typed, let me actually back up. They could have typed S equals, I think it comes to 0.9396. But S, remember, is the sample standard deviation. That's not the population standard deviation. All right, we picked data because we have a list of data. And our null was 5. I named my list A. We're testing to see if it's smaller than 5. And this just tells the calculator where to print the results. And you're good to go. There it all is. P-value looks large. It's bigger than 5%. We're going to fail to reject. There's the mean. There's the sample standard deviation right there. That's why we did a t-test, because this does not say sigma. Remember, this is based off of 15 random spots in the stream. It isn't the standard deviation. I don't know how you could possibly measure that. All right, let's solve this thing. X bar was 4.7713. S is 0.9396. I am doing a t-test. Or you can write down the formula is X bar minus mu over S over square root of N. Either of those count for the same points. Calculator did all the math for us. It got a negative 0.9425 t-score. And the p-value is the proportion of t smaller than that t-value, which the calculator told us is 1809. That's a large p-value because it is bigger than alpha. All right, last part, conclude. I'm going to do my typical conclusion, and then I'm going to go up there and answer their question. We failed to reject. HO. Evidence does not suggest the true mean DO level in the stream is less than 5 milligrams per liter. So that's my traditional conclusion. But look up there, it says, do we have convincing evidence that aquatic life are at risk? Make sure you go back up, look at what it would mean for aquatic life to be at risk. That's whenever DO levels are too low. So we are going to say it appears that aquatic life say are or is? I'm going to say are not at risk. And my reason is because of that, right above it. True mean dew level in the stream is not less than 5. It's really confusing because we did get a mean. Let me erase that arrow. You don't have to have that arrow on your paper. It's really confusing because that sample mean right here is less than 5. But remember, it's not significantly less. These were just 15 random spots in the stream. What if it was a bad sample? It's not shocking, so I'm not going to reject HO. Down here kind of explains that risk. Given your conclusion, what kind of mistake might you have made? Well, since we failed to reject, that means we are risking a type 2 error. What does this mean in context? If our conclusion is wrong, aquatic life is at risk. Oh, I said the other. Above there I said are at risk. Here I said is at risk. I don't know. You guys check my grammar. Who knows? But I know it is aquatic life is in danger. So hopefully that made sense. See y'all in class.